Hi students, it's Mrs. Carreri, and I am going over the setup of the lab that you will complete while I am away. This lab involves a claim that a student makes about a track, a low friction track, and a cart. The student has made the claim that the energy of the cart earth system at the top of the track is equivalent to the energy of the cart earth system at the bottom of the track. And so we got to determine if that claim is true. So what kind of energy does the cart have at the top? The energy hopefully you see, since it is not moving and does not have a spring involved, is only potential energy due to gravity, and the earth is part of that system, so there is potential energy due to gravity. If we assume our zero line at the bottom is located at the same height that the cart is at when it reaches the bottom, the only type of energy that the cart has at the bottom is kinetic. So I need to have some way of determining the potential energy due to gravity and the kinetic energy of the cart. I also want to do this lab without having to measure the mass of the cart. And so if I were to compare this energy, pretend that's 1 joule, I'm expecting that energy to be 1 joule. If I divide the two, I should get a value of 1. The fraction of kinetic energy to, or the ratio of kinetic energy to the potential energy due to gravity of this system, assuming no friction, should be 1. If it's greater than 1, then if kinetic energy is in the numerator and potential energy is in the denominator, it means I either gained or lost energy, and I'll let you answer that. If it's less than 1, then it either lost or gained energy based on the fact that kinetic energy was divided by the initial energy, okay? So let's talk a little bit about the setup. One of the things I need to know is the height of the center of mass of the cart relative to some reference line. Well, we just got finished saying our reference line is going to be at the bottom. That's kind of difficult to know. Okay, well, where's the reference line relative to the center of mass of the cart? Somewhere in the middle of the air, and that is almost impossible for you to accurately measure. So what we're going to do is we're going to measure the location of the cart relative to the top of the table at both locations. Now, I'm going to use the back of the cart, the back side of the cart. It is up against the pulley. It will start here every time. I'm going to make a tick mark. I can put a piece of tape on it, make a tick mark on the tape, and then I'm going to measure the amount of centimeters from the top of the table, and I'm going to do it as accurately as possible. So try to keep that ruler nice and plumb to the side. Don't have it at an angle. Maybe use a piece of cardstock or something to then be able to see exactly where it lands. And so just for your reference, that's approximately 15 centimeters. Now, when I get to the bottom, I'm going to then examine, and this will be the same every single time. So you can, once you make this tick mark on this reference, you won't need to make it again. I will examine, I'll say, okay, the photo gate, and you'll learn how to set this up, is now it sees the cart, it doesn't see the cart. It sees the cart, it doesn't. So when the light is on, approximately somewhere in the middle of that on off, I will then make a piece of paper or a piece of tape, and I will mark a tick mark at the back of the cart, since I was at the back of the cart there, and then I can measure the height that the cart was located from the top of the table, same reference as that. Now I can then subtract those two values, and just for chagrins, I'll give you a number so you have an idea. Make sure you start from 0. I was not at 0. Okay, that number approximately is about 4.9 centimeters, okay? So I would take, I think it was 15 centimeters minus 4.9 centimeters, and that delta is the height difference of the center of mass to the center of mass. And make sure to convert to meters. Okay, let's talk about the approach to the lab. We're going to make this, we're going to prove this And doing this one time is not going to be acceptable ever. So I've got it set up with one height delta. I'm going to go and release it. I will get a velocity at the bottom because the photo gate's going to give me the velocity of that cart at that spot. You do need to learn how to set that up. That's one velocity. Was it accurate? Did it measure it properly? I don't know. Let's do it at least a couple more times to confirm that the data that the photo gate gave me is consistent. So I want to do it again. I got another velocity. They should be pretty close to one another. I'm getting pretty consistent results. I'm going to do it again. I got 3 velocities now with this setup, okay? And I'm going to, if one of them's cattywampus, you might throw it out. It could be a bad data point. Confirm you're getting 3 consistent velocities. They're very close to one another from me. What is determining the velocity is the photo gate and this little piece of paper that I have taped to your cart that has a certain width. The photo gate's laser is blocked for a certain period of time, which it measures the time. And then I tell the photo gate computer how wide this is. So if this was blocked for a really short period of time, then this had to go through it very quickly, and it knows how wide it is, and it can calculate the velocity of the cart. Okay, that's only one setup. Now, I don't want to just do this at one setup. Maybe I now need to change it to another height. There's a whole bunch of books that I have now added to your cabinet above the files back there, so you can grab books. Now I have another height. I can do this experiment again. I will then also, once again, the tick mark should be the same because you are going to have the same exact setup. Now I could, if I wanted to, if I get really high, use this tape. Make sure you're on the meter side. And I have found that you want to confirm that this metal part, we don't really care, we just want the delta. So even if it's not a perfect number, push that metal part to the top of the table, make sure it's nice and perpendicular, and then you can measure it. And then go to do the same thing over here. Push the metal to the top and confirm and measure it again. If you use this tape for the top, use that tape for the bottom, just because I don't trust where the zeros are on each one. If you use it for both, and since you're subtracting, any error related to that will be gone. So we will run that again, 3 velocities. And I want another height. Now you'll notice that I have this set up off the end of the table, so I can get this at a very high angle, okay? If you need to get creative on heights, try not to go too much higher than maybe 1 book on top of your lab box. Let me see if that's possible. Yeah, that's about as high as I want to go. I don't want chaos here. I don't need carts flying. I would really appreciate it if somebody was here waiting for the cart so it doesn't just go flying. We don't need our motion detector in this experiment, but someone needs to catch that. You do not want to put your hand here because that will interfere with the photo gate's operation. I think that explains the approach to what we're trying to accomplish. I'll talk about one more thing. If this energy is equal to this energy, if the potential energy to gravity is equal to the kinetic energy here, assuming that the zero line is located there, and I wanted to know the ratio of the kinetic energy to the potential energy due to gravity. The ratio is the kinetic energy divided by the potential energy due to gravity. Well, if they're identical, then that should be 1. Now, what if the ratio was less than 1? That means this divided by this is less than 1. Did I lose or did I gain? I'll let you answer that. If the ratio was above 1, did I lose or did I gain? Okay. By determining the ratio, mass is in the numerator and mass is in the denominator, and I don't have to determine the mass of the cart. Mass doesn't matter, and it shouldn't, and maybe we can prove that. Okay, that's my video. Hopefully that helps you, and I will now do a separate video on how to set up the photo gate.